Sydney. I'm from Group 1.
Hello.
Okay, yeah.
My name is Muhammad Ilham Bin Bakri. This is my matrix number, and I'm from Group 1.
Hello, my name is Hamizan and this is my matrix number.
From Group 1.
Assalamualaikum everyone. We are here to discuss about DC and AC motors. So my name is Shahab Imran and now I will talk about DC. So how does a DC motor work? The main principle behind the working DC motor is the electromagnetic law, according to which a current carrying conductor placed in a magnetic field experiences a force, and the direction of the force is given by Fleming's left-hand rule. That's what I'm saying. In order to understand the basic principle, we used to understand the basic construction feature of a DC motor. So now I will show you the picture that how does a DC motor structure look like. So how does a DC motor work? The main principle behind the working DC motor is the electromagnetic law, according to which a current carrying conductor placed in a magnetic field experiences a force, and the direction of the force is given by Fleming's left-hand rule. That's what I'm saying. In order to understand the basic principle, we used to understand the basic construction feature of a DC motor. So now I will show you the picture that how does a DC motor structure look like.
So this picture you can see is about permanent magnetic DC motors, and this one is about series DC motors, and now you can see a shunt DC motor. So last one, the fourth one is compound DC motors.
Okay. When do we use the DC motors? DC motors are suitable for many applications, including conveyors, timetable, and other for the adjustment of speed and constant or a low speed torque are required. So how can we control the speed of the DC motors? There are three ways to control the speed of a DC motor. The first one is the flux control method. The second one is the armature control method. And the last one is the voltage control method. So what is the flux control method? In this method, the magnetic flux due to the field winding is varied in order to vary the speed of the motor. As the magnetic flux depends on the current flowing through the field winding, it can be varied by varying the current through the field wind. This can be achieved by using a variable resistor in series with a field winding resistor. Okay, initially when the variable resistor is kept at its minimum position, the related current flows through the field winding due to the related supply voltage, and as a result the speed is kept normal. The second one is the armature control system. It's a method. So with this method, the speed of the DC motors can be controlled by controlling the armature resistance to control the voltage drop across the armature. This method also uses variable resistors in series with the armature. When the variable resistor reaches its minimum value, the armature resistor is at normal one, and therefore the armature voltage drops. When the resistor value is gradually increased, the voltage across the armature decreases. This is turn leads to decrease in the speed of the motor. So the third one is the voltage control method. Both the above mentioned method cannot provide speed control in desirable range. So that means the speed decrease, but not in a desirable range. So the flux control method can affect commutation, whereas the armature control without control method involves huge power loss due to shortage of resistance in series. Therefore, a different method is always desirable, and that method is the voltage control method. In such method, the field winding receives a fixed voltage and the armature gets a variable. On such technique of voltage control method involves the use of a switchgear mechanism. Is to provide a variable voltage to the armature, and the other one uses an AC motor driven generator to provide variable voltage to the armature. So this method proves to be very efficient as a power loss is kept minimum, and it does not involve the use of any complex equipment.
Hey, Assalamualaikum and a very good evening. So my part is AC motors. There are two types of AC motors, which is induction motors and synchronous motors. We're going to talk about how AC motors works. So the induction motor, or as known as a synchronous motor, always relies on a small difference in speed between the stator rotating magnetic field and the rotor shaft speed, called slip, to induce rotor current in the rotor AC winding. As a result, the induction motor cannot produce torque near synchronous speed, where induction or slip is irrelevant or ceases to exist. In contrast, the synchronous motor does not rely on slip induction for operation and uses either permanent magnets, salient poles, having projecting magnetic poles, or an independently excited rotor winding. The synchronous motor produces its rated torque at exactly synchronous speed. The brushless wound rotor, doubly fed synchronous motor system, has an independently excited rotor winding that does not rely on the principles of slip induction of current. The brushless wound rotor, doubly fed motor is a synchronous motor that can function exactly as the supply frequency or sub to super multiple of the supply frequency. Thank you. Okay, now I'm going to talk about when the induction motors is applied. It is used in almost every process. Induction motors are mainly used in water pumps, kitchen appliances, fans and air conditioners, automobiles, common industrial machinery like boiler pumps and compressors. So, in controlling the AC motors, AC motors is adjustable speed drives. The traditional way to control the speed of a wound rotor induction motor is to increase the slip by adding resistance in the rotor circuit.
So I will talk about the differences between AC and DC. AC motors are powered from alternating current, which is AC, while DC motors are powered from direct current. And then the DC quantity that you supply to a brush DC motor gets converted into alternating quantity in the armature circuit by the help of commutator and brush assembly. Then in an AC motor, the inversion or conversion of quantities, which is commutation, is not required or be done. AC motor are usually seen in applications where the motor speed needs to be extremely controlled. AC motors work best in applications where power performance is sought for extended periods of time. And then all DC motor are single phase, but AC motor can be single phase or three phases. Then in DC motor, the armature rotates while the magnetic field doesn't rotate. While in AC motor, the armature does not rotate and the magnetic field continuously rotates. AC motor doesn't use brushes while DC motor they use brushes, while AC motor can withstand wear and tear but have a longer lifespan. And lastly, DC and AC motor have differing means. Do not use brushes while DC they use brushes, and AC motors can withstand wear and tear and have a longer lifespan. And lastly, there are some ways to control the speed of the motor, which is while DC motors are controlled by varying the armature windings current, and AC motor will just simply vary the frequency. Finally, between AC and DC motors, which one is commonly used? You know? Don't know, right? So the most used motors is AC. Why? This is because DC motors are larger and more expensive. What is the meaning of that? It is DC motors they need brushes, magnets, etc. to create a changing direction of current and hence are bigger. AC motors don't have that problem. They run off varying current and the construction can be simple. So that's it. Thank you. AC motor does not use brushes while DC motor use brushes. And then apa nak kayu basikal lah.